Have you ever wondered what's really going on behind the scenes of humanity's greatest space adventure? The moon has secrets that could rewrite everything we thought we knew about space, time, and even life itself. The strange events on Apollo 10 were just the beginning. In today's video, we're diving deep into the mysteries of the moon that NASA is still trying to unlock. But some of these discoveries are so bizarre, they might just leave you questioning reality itself. Stick around, because what we uncover might shock you. Let's start with a mystery that even the bravest astronauts couldn't explain: Apollo 10. In 1969, Apollo 10 astronauts were orbiting the moon, but something unexpected happened while they were in deep space. During their mission, they heard an eerie, bizarre sound on their spacecraft. Imagine this: you're floating in space, hundreds of thousands of miles away from Earth, and suddenly, a sound that no one can explain starts echoing through your radio. It's unlike anything you've ever heard before, almost like an electronic theremin, the kind of sound you'd expect from a creepy science fiction B-movie from the 1950s or 60s. The astronauts were baffled and confused. What was this noise? Could it have been some kind of ghostly interference from space? Well, turns out it wasn't anything supernatural. The source of the strange sound was actually just interference from the spacecraft's radio system. The Apollo spacecraft were equipped with cutting-edge technology, but by today's standards, they were quite primitive. Despite being state-of-the-art at the time, the radios were relatively noisy, picking up bumps, bangs, and even the whirring of fans and engine noise. What the Apollo 10 crew heard was just an interference effect from those early 1960s communication systems. This eerie sound that baffled the astronauts was one of the first mysterious events that drew our attention to the far side of the moon and the unexplored regions of space. But the strange happenings didn't stop there. Fast forward to the Apollo missions, where astronauts traveled to the surface of the moon. 2 astronauts would land, while the third stayed in the command module to orbit the moon alone. The solo orbit journeys of astronauts like Michael Collins from Apollo 11, Dick Gordon from Apollo 12, Stuart Rosa from Apollo 14, Al Worden from Apollo 15, Ken Mattingly from Apollo 16, and Ron Evans from Apollo 17 are some of the bravest feats in space exploration. While they didn't land on the moon, their time spent orbiting it in isolation. Observing the lunar surface from an entirely new perspective was equally critical to our understanding of the moon's secrets. These astronauts spent days making detailed lunar observations from orbit, mapping features that no one had ever seen before. Apollo 15 astronaut Al Worden often said that his time alone in orbit around the moon was some of the best he had during the entire Apollo mission. Imagine the sight of the far side of the moon, a place that no human had ever laid eyes on before. The views, according to Worden, were unlike anything you could imagine. He described the experience as sheer awe when he saw the stars, and said that the number of stars was so vast it looked like a sheet of white, with each star a sun in its own right. This was not just a mission about collecting data, it was a personal journey of discovery for the astronauts themselves. But there's a mystery that's even more intriguing: why did we only explore the near side of the moon? After all, scientists have known about the far side of the moon for decades. Why didn't we land there? Well, the answer is simple. The reason we didn't land on the far side during the Apollo missions was that we needed to maintain constant contact with Earth. The far side of the moon is hidden from us, it's never visible from Earth, and thus, if something went wrong while astronauts were on the surface, they wouldn't have been able to communicate with mission control. This is a significant risk. Today, however, this would no longer be an issue. Satellites could be placed in lunar orbit to relay communications. The far side of the moon is growing in interest to scientists, as it may hold the answers to some of the biggest questions in space exploration. Imagine placing radio telescopes or optical telescopes there. The far side of the moon is shielded from Earth's radio interference, making it a perfect location for deep space observatories. Furthermore, because it's never illuminated by Earth's daylight, scientists could use telescopes there to study the universe in unprecedented detail. These observatories could be built inside craters to shield them from solar radiation, allowing us to peer deeper into space than ever before. But there's more to the far side of the moon than just observatories. Scientists are also deeply curious about the differences between the far side and the near side. Why is the far side so vastly different in appearance? This growing interest in lunar exploration is fantastic news for planetary scientists, hoping to understand more about our rocky neighbor in space. These scientists are eager to find answers to some burning questions. According to Noah Petro, a research scientist at NASA's Goddard Space Flight Center, one of the fundamental unknowns is how the moon formed and how it relates to Earth. How did the moon come to exist, and how did it evolve? The Apollo 11 mission provided the first clue when astronauts brought back 50 pounds of moon rocks, which initiated decades of research into understanding the moon's origins. The strongest theory for the moon's formation is that it began as a magma ocean, a massive ball of molten lava orbiting Earth. This theory led to another, even more exciting hypothesis: what if the moon wasn't formed independently but was born from Earth itself? According to this idea, a Mars-sized object collided with Earth, ejecting debris into orbit. That debris eventually coalesced into the moon. Evidence from moon rocks strongly supports this theory, suggesting that the material that formed the moon also contributed to the formation of Earth. However, this theory is still not perfect, as we have no way of definitively confirming that the moon was created by this giant impact. In addition to understanding the moon's formation, Apollo moon rocks have also presented another puzzling question: why aren't these rocks as old as the moon itself? The moon is over 4.5 billion years old, meaning it was formed around the same time as the solar system, so you'd expect to find rocks from the moon's early days. However, analysis of the Apollo moon rocks shows that the majority were created by impact events around 3.9 billion years ago, but almost none of them date back to the moon's first 600 million years of existence. This creates a mystery. According to scientists, impact events should have become less frequent as the planetary accretion process wound down, so it's puzzling that there aren't more rocks from those early collisions. The most likely explanation is that the moon was subject to intense bombardment around 3.9 billion years ago, the period known as the Late Heavy Bombardment, or lunar cataclysm. But the lunar cataclysm theory is not without its critics. What if this event never occurred? What if the rock scientists are studying actually come from a more recent impact? This would upend our understanding of the early solar system. To resolve this, scientists are planning to visit other areas of the moon that have not been contaminated by these large impacts, such as the South Pole or the far side. If samples from these regions show that they are older than 3.9 billion years, it would cast doubt on the lunar cataclysm theory and open up new possibilities for understanding the early solar system. Speaking of the lunar South Pole, this region is of particular interest to scientists because it's believed to contain water. In 2009, NASA confirmed the discovery of water on the moon, and subsequent studies suggest there may be large amounts of water ice beneath the surface, especially at the lunar poles. This discovery is significant because it could be used for future lunar missions, potentially providing the necessary resources for life support and even rocket fuel. But how did this water get there in the first place? Could it have been delivered by comet impacts, or did it form through interactions with solar winds? Scientists have three main theories about how the moon's water originated: asteroid and comet impacts, interactions with solar winds, or volcanic activity that released water from the moon's interior. Initial data has provided promising clues. The Lunar Crater Observation and Sensing Satellite (LCROSS) mission, which impacted the lunar surface at the South Pole, found water and other materials that are common in comets, suggesting that some of the water on the moon came from space rock. To definitively answer the question of how much of the moon's water came from comets or solar winds, scientists will need to conduct more in-depth studies, including analyzing the isotopic composition of samples from the moon's surface. But it doesn't stop there. Another mystery that has recently come to light is the presence of something massive beneath the moon's surface. Below the largest impact crater in the entire solar system, scientists have detected an unusual mass. What is it? Could it be a hidden metal body left by an ancient impactor? This anomaly is massive enough that it could affect the moon's gravitational field. And there's more. Scientists also believe that the moon is still tectonically active. They've discovered something called moonquakes occurring fairly regularly on the moon. These moonquakes are caused by factors like tidal stress from Earth's gravity and meteorite impacts, but there are also shallower moonquakes without an obvious cause. These new discoveries raise even more questions. What's causing the increased frequency of moonquakes? And what exactly is this hidden mass beneath the surface? Scientists are actively working to answer these questions, but with limited data, the mystery remains. To get a clearer understanding of what's going on beneath the moon's surface, it would be necessary to deploy a global seismic network on the moon. Such a network would provide valuable insights into the moon's seismic activity and its internal structure. Perhaps the most intriguing mystery of all is why we only ever see one side of the moon. The moon is tidally locked to Earth, meaning that one hemisphere is always facing us, and the other is hidden in darkness. This phenomenon is not uncommon for moons in our solar system, but the exact cause of tidal locking remains a mystery. Understanding tidal locking could help scientists learn more about the moon's early history, as well as how similar processes might occur on exoplanets outside our solar system. And as scientists continue to uncover the moon's secrets, we're only beginning to understand the true nature of our cosmic neighbor. From lunar cataclysms to hidden water ice, moonquakes, and potential alien life, the moon is still full of mysteries waiting to be explored. Each new discovery offers a deeper insight into the history of our solar system and perhaps even the origins of life itself. As NASA and other space agencies prepare for the next wave of lunar exploration, there's never been a more exciting time to be a part of humanity's quest to understand the moon and everything it holds. So, what do you think? Are there hidden truths on the moon waiting to be uncovered? Leave a comment below, and don't forget to subscribe to our channel to stay updated on all the latest lunar discoveries. Thanks for watching, and we'll see you next time.